What's up guys, this is Massey. Welcome to another video. In this video I want to talk about multiplying a vector by a scalar. So as you see here, if we have a vector v and a scalar k, and this k belongs to real number, when we multiply these two, we're going to have scalar multiple, which the magnitude of this new vector is going to be k times magnitude of v, as you see here. So it's going to be magnitude of k times magnitude of vector v. If k is positive, then the kv has the same direction as original vector. If k is negative, then kv has the opposite direction to v. A vector and its scalar multiple are parallel, but sometimes we have the same direction, sometimes we have opposite direction, depending on the sign of the value of k. Let's see some examples. Vector 2v has double the magnitude of vector v and has the same direction. Why? Because 2 is positive, so 2v has the magnitude double than the original vector, and it is on the same direction. So parallel and on the same direction. On the other hand, we have vector negative 3u has triple the magnitude of vector u, but has the opposite direction. Why opposite direction? Because we have negative 3 in front of it. So we still have parallel vectors, but the direction is different. Let's see another example. In this example, it asks us to represent scalar multiplication. Consider vector u with magnitude of 100 kilometers per hour at a quadrant bearing of north 40 east, as you see it in the picture. And then ask us to draw a vector to represent each scalar multiplication, described in words as follows: 3u, 0.5u, and negative 2u. So if I go one slide back, so if you want to find out 3u, the magnitude is going to be 3 times 100, so magnitude is going to be 300, and since it's positive, it's going to be on the same direction, which is n40e. So let's see this answer now. So as you see here, the magnitude is 300 kilometers per hour, and we have it on the same direction. So that's going to be the answer to 3u. Now let's see what is going to happen to 0.5 times u. So since 0.5 times u is 0.5 is positive, it's going to be exactly on the same direction, but it's going to be shorter. It's going to be half. The magnitude is going to be half, but on the same direction. So the velocity this time is going to be 100 divided by 2, which is 50 kilometers per hour at a quadrant bearing of north 40 east. Now for the last part of this example, we are dealing with negative 2u. For negative 2u, if I go back to the original vector, it is going to be 2 times 100, which is going to be 200, but it is going to be on the opposite direction. Why? Because we are dealing with negative 2, negative number. So the magnitude is going to be double, but the direction is going to be different. As you see here, we have this new vector in the opposite direction. Velocity is 200 kilometers per hour at a quadrant bearing of south 40 w. Next concept is going to be collinear vectors. What are collinear vectors? Vectors are collinear if they lie on a straight line when arranged tail to tail. The vectors are also scalar multiples of each other, which means that they are parallel. So as you see here, we have v and we have 2v. Both of them are collinear and both of them are parallel. The following statements about non-zero vectors u and v are equivalent. U and v are scalar multiples of each other. That is, u equals to k times v, and k is the scalar, but u and v are vectors. It means that u and v are collinear and u and v are parallel. Vector properties are for scalar multiplication. So we have these properties. First one is distributive property. For any scalar, which is k belongs to real numbers, and any vectors u and v, we can say k times u plus v equals to k times u plus k times v. And the next property is going to be associative property, and for any scalar a and b belongs to real number and any vector v, we can say a times b times v equals to a times b times v. And the last property is going to be identity property. For any vector v, 1v equals to the same thing. So when we multiply it by 1, it is going to be exactly like the original vector. It means that the magnitude doesn't change and the direction doesn't change as well. And then we are talking about linear combination of vectors. Given two vectors u and v and scalars s and t belongs to real numbers, the quantity s times vector u plus t times vector v is called the linear combination of vectors u and vector v. This concept is really important in vectors part. Linear combination of vectors can be formed as s times u plus t times v. For example, 2 times u minus 7v is a linear combination of u and vector v, where s is 2 and t is negative 7. Let's see this example. In a trapezoid ABCD, BC and AD are parallel, and AD is 3 times bigger than BC. It means that they are parallel. It means that BC and AD are parallel, but the magnitude of AD is 3 times bigger than BC. So let's consider AB as U and BC as V. Then express AD, BD, and CD as linear combination of U and V. So first of all, we're going to say AD, since it's parallel with BC and is 3 times bigger than that, we can say AD equals to 3 times vector V. BD is going to be summation of BA and AD. BA is opposite to AB, and AB is U, so BA is going to be negative U. Why negative U? Because it's going to be the same vector, but in the opposite direction. Same magnitude, but opposite direction. And next one we have AD. AD, we already defined that as 3V. So BD is going to be negative U plus 3V. CD equals to CB plus BA plus AD. CB is negative V, which is the same as BC but in opposite direction. BA opposite to U, which is negative U, and AD is 3V. So we have negative U, negative V plus 3V. When you simplify it, it's going to be negative U plus 2V. So let's see the key concepts and wrap up these slides. When you multiply a vector by a scalar, the magnitude is multiplied by a scalar and the vectors are parallel. The direction remains unchanged if the scalar is positive, but it becomes opposite if the scalar is negative. For any vectors u and v and scalars k and m, we can say k times u plus v equals to ku plus k times v. That's called distributive property. On the other hand, we have k times mu equals to k times m times vector u. And also we have identity property, which is 1 times vector u equals to vector u. Linear combinations of vectors can be formed by adding scalar multiples of 2 or more vectors.